In my earlier video, I discussed about graphs, like how you can store it using adjacency list. I hope you're familiar with that part. So the next thing is like how can you traverse a graph using some of the standard algorithms. So breadth first search or breadth first traversal is one of the popular algorithms that is used to traverse a graph, and the popularity is more so because of its numerous applications. Let me show you an example. I've written a full post or article for this, so I'll post a link um, in this video, and you can read that also. But let's talk about the friendship graph that I'd shown you guys earlier. So in this graph, if I have to do a breadth first traversal, then the way it works is first I start from one of the nodes, say Ankur, then I traverse, the adjacent nodes like Reena and Dikshit who are linked to Ankur, and then we pick one of them, say Reena, and we visit its, its adjacent node, which is Nidhi. Similarly, we do for Dikshit, we visit Suresh, and then we visit Mohan. So it's more like we are traversing this graph level wise. First level is this Ankur, which is root in our case. Second is these two internal nodes, which are adjacent to this node. And then we move to the next level. So it's like level wise traversal. So interestingly, when you visit this graph using breadth first traversal, then you can also create a tree, a breadth first tree, and that tree can be used to find shortest distance, say from this node Ankur to rest of the folks. So basically, you know how closely someone is related to Ankur, or how close a friend that person is. So I know that Nidhi has one connection which is connecting her to Ankur. So that ways you can have various permutations and combinations. You might have seen that already in social networking. Although it's the level of complexity is far more, but that's the basic idea. So if you go through the article which I've written, I have mentioned the applications which are there. Like if you're familiar with the mathematical terms for graphs like path and coloring, those are not very complex, but they require a little bit of familiarity. Then you will understand what I'm talking about here. And I've also listed the algorithm that you can use to do this. One of the key things is in this algorithm, we'll be using queues. Queues are basically first in, first out, a pretty standard data structure which you can use. And we keep on enqueuing a node and its adjacent nodes, and then we keep on dequeuing it. So if you see this algorithm, let me explain you here what I'm trying to say. So first I enqueue this node Ankur, okay, and then I dequeue it to find its adjacent nodes, and then I enqueue each of these. Then I keep on dequeuing it one by one, pulling it out from the queue and then traversing its corresponding elements. So it's not very complex. Only thing is, you know, this is kind of built on the earlier graph algorithm, I mean data structure which I showed you. So the key method in this program, which is also available on GitHub, the key method will be your BFS, which I have added to the previous one. And if you see here, it does what I'm talking about. So initially I take this vertex 0, which is nothing but Ankur here, and I enqueue it. I put it in the queue, and then I start to iterate until the queue size is 0. So every time I traverse the adjacent nodes, and I keep on checking whether the node has been visited or not. So once you visit a node, you can you can label it as visited, and that ways you know which node you have visited and which are still pending. And then you keep pushing it to the queue, and you keep dequeuing and do that. So go through this code piece, or better if you can try on your own, I'll suggest that. Do that, and if you have any questions on this, or you want me to address some other topic in this, then just drop me a comment. I hope this helps you guys.